Reverse engineering refers to the process of taking something apart in order to see how it works. There are several reasons why one would want to reverse engineer Android apps. Two of the most popular reasons are analyzing potentially malicious apps, for example, after an incident or as an AV researcher, uncovering security vulnerabilities and privacy flaws, for example, when conducting a pen test or bug bounty. An important thing to keep in mind is that when reverse engineering, you rarely have the application source at hand. As a reverse engineer, you are usually either given a device with the suspicion that it contains some sort of malicious code, or you are given a suspicious standalone binary, or APK. In both of these cases, you are going into the analysis blind since you do not have any source code or documentation to start off with. As a reverse engineer, the main question you are trying to answer is, what is the application doing? After determining this, you may even want to dig deeper and answer the question, how is it doing what it's doing? In some cases, you might even want to ask who is responsible for this. For example, using the findings to identify the responsible malware author. To answer these questions, you need to make use of a number of tools, which usually fall under one of two analysis categories: static analysis and dynamic analysis. Besides static and dynamic analysis tools, you will also find a number of supporting tools, such as the Android emulator, that will enable and simplify the analysis process. With static analysis, an app is analyzed by looking at its code. As mentioned earlier, as reverse engineers, we are not usually handed the source code on a silver platter. This is why we need to make use of special tools such as decompilers in order to extract the application's code. A decompiler examines the binary and translates its contents from a low-level abstraction to a higher-level abstraction. In a simplified example, a decompiler is able to take an APK as an input and produce the pseudo-Java source code as an output. Once you have the source code in hand, you are able to search through it and identify the app's behavior through a combination of logic and method calls within the code. In order to understand the code, there is no need for the reverse engineer to be a developer. That being said, a reverse engineer's job would be much easier if they understood the fundamentals of app development. Dynamic analysis involves executing the suspicious app and analyzing the behavior during execution. The idea here is to execute the app in a contained environment and monitor different behaviors, such as file access and API method invocation. A popular approach for analyzing apps during execution involves instrumenting the target app and adding monitoring capabilities to specific parts of the code. A big advantage of this approach is that it is Android version independent. Other dynamic analysis techniques that involve attaching probes to the Android device or emulator have the problem that the probes often require patching and updates with every new Android version release. An example of this is the popular dynamic analysis tool DroidBox. This is an excellent tool, however it only supports an Android 4.1 emulator, which is extremely old. In the world of reverse engineering, automation is the name of the game. As a reverse engineer, you will find yourself performing repetitive, monotonous tasks, and if these tasks can be automated, then they should be. Automated tools can at the very least be used to determine a starting point and a potential way forward. A popular form of such automated tools includes malware sandboxes. These sandboxes usually apply a number of static and dynamic analysis techniques to an uploaded sample and present a centralized report of the findings. As mentioned earlier, there is no need for a reverse engineer to be an app developer. However, it is unlikely that an Android reverse engineer will be able to work without using the Android Studio IDE at some point or another. Be it for testing some chunks of code or for using the associated tools, Android Studio is a great and powerful tool that is definitely worth having in your arsenal. Most of the Android reverse engineering tools do not run on Android, but rather on an analysis machine, such as Windows, Linux, or Mac. This is where the Android Debug Bridge, ADB, comes into play. This tool ships with the Android SDK, and it is responsible for most of the communication between the Android device or emulator and the analysis machine. Below are a set of reverse engineering tools that are freely available to reverse engineers. While the list is not meant to be comprehensive, it includes most of the must-have tools that will allow a newcomer to perform sophisticated reverse engineering tasks. APK Tool is a tool for reverse engineering third-party, closed, binary Android apps. It can decode resources to their nearly original form and rebuild them after making some modifications. It also makes working with an app easier because of the project-like file structure and automation of some repetitive tasks like building APK, etc. Bytecode Viewer is a tool containing 6 different Java decompilers, 2 bytecode editors, a Java compiler, plugins, searching, supports loading from classes, jars, Android APKs, and more. AndroGuard is a full Python tool to play with Android files. You can either use the CLI or graphical front end for AndroGuard, or use AndroGuard purely as a library for your own tools and scripts. Frida is a dynamic instrumentation toolkit for developers, reverse engineers, and security researchers. Objection is a runtime mobile exploration toolkit powered by Frida, built to help you assess the security posture of your mobile applications without needing a jailbreak. There are a few online Android malware analysis platforms, but the best one we've come across is apklab.io. There is also Kudos, which does not have all the cool state-of-the-art analysis features offered by apklab, but it is a good resource for finding malware samples. apklab.io is a mobile threat intelligence platform by Avast. Kudos is a collaborative platform that combines the power of online analysis tools with social interactions between the analysts over a vast APKs repository. Android Studio is the official integrated development environment, IDE, for Android app development, based on IntelliJ IDEA. On top of IntelliJ's powerful code editor and developer tools, Android Studio offers even more features that enhance your productivity when building Android apps. Android Studio 3.0 and higher allow you to profile and debug APKs without having to build them from an Android Studio project. However, you need to make sure you're using an APK with debugging enabled. Smallydea is a Smalley language plugin for IntelliJ IDEA. Android Debug Bridge is a versatile command line tool that lets you communicate with a device. The ADB command facilitates a variety of device actions, such as installing and debugging apps, and it provides access to a Unix shell that you can use to run a variety of commands on a device. Android Virtual Device is a configuration that defines the characteristics of an Android phone, tablet, Wear OS, Android TV, or automotive OS device that you want to simulate in the Android emulator. The AVD Manager is an interface you can launch from Android Studio that helps you create and manage AVDs. In this case study, we will have a look at an Android file encrypting ransomware, SimpLocker. This malware perfectly sums up how the combination of the above-mentioned tools and techniques can allow a reverse engineer to understand the ransomware's functionality. Moreover, it demonstrates the ability to use the knowledge gained through reverse engineering to develop a ransomware decryption tool. SimpLocker was first discovered in 2015, and it is a relatively straightforward sample that parses through a specific set of file types and encrypts them. Upon receiving the payment, the app communicates with the command and control server and receives a command to decrypt the files. The interesting thing about this sample is that within the code, it actually contains the relevant information that can be used to develop a decryption tool. Placing the reverse engineering steps into the context of this article, through automated analysis, we can see the encryption being used, file access, permissions, crypto functions, starting points, points of interest, etc. Through dynamic analysis, we can see the encryption in action, and if the C2 is still active, then we are able to obtain C2 commands received during execution. We can also extract encrypted files on which we could test the decryption. Through static analysis, we can obtain source code, including decryption functions, and in the case of SimpLocker, the encryption and decryption keys. Through app development, we can create a basic application that will decrypt the encrypted files based on the knowledge obtained through our analysis. We can then test the decryption tool on the encrypted files obtained during the dynamic analysis. If you are interested in getting your hands dirty and delving into the world of Android reverse engineering, feel free to follow our Udemy course. The course will take students through the process of developing a basic Android application, which will provide insight into the inner workings of an Android APK. Upon completion, the students will have their own analysis environment, along with the knowledge required to analyze suspicious APKs. The student will also be taken through the reverse engineering of the SimpLocker Android ransomware and will use the findings to develop their own SimpLocker decryption tool.